The Sun, a giant ball of burning gas. It sits at the center of our solar system. Everything revolves around it. Life on Earth depends on the Sun. It gives us light and warmth. Without the Sun, our planet would be a very different place. The Sun is incredibly powerful. It's hard to imagine its size and energy. But it wasn't always the star we know today. Billions of years ago, the Sun was just a cloud. This wasn't an ordinary cloud, it was a giant molecular cloud, much bigger than our solar system. This cloud was mostly hydrogen and helium, the simplest elements. It also had tiny bits of other elements like carbon and oxygen. These were remnants of even older stars. This cloud was cold and dark, but something amazing was about to happen. Gravity started to pull the cloud together. Gravity is a force that attracts everything with mass. The more mass, the stronger the pull. As the cloud got smaller, it started to spin. Imagine a figure skater pulling their arms in during a spin. They spin faster, right? The same thing happened to the cloud. The center of the cloud got hotter and denser. This was the beginning of our Sun. The center of the cloud kept getting hotter and denser. Finally, it reached a critical point. The pressure and temperature were so high that hydrogen atoms started to fuse together. This fusion process released a tremendous amount of energy. It's the same process that powers the most powerful bombs on Earth, but on a much grander scale. This is how the Sun was born. It became a star, a giant ball of plasma held together by its own gravity. The Sun's core is like a giant furnace. Here, hydrogen atoms are constantly fusing into helium. This process releases the energy that powers the Sun. Imagine 4 marbles fusing into one slightly bigger marble. The combined mass is slightly less than the original 4. This tiny difference in mass is converted into energy. According to Einstein's famous equation, E equals mc squared. This energy slowly makes its way to the Sun's surface. It takes thousands of years for this journey. But it's what gives us light and warmth here on Earth. Section 6. Layers of the Sun. The Sun isn't just a homogeneous ball of fire, it has layers, like an onion. Each layer has its own unique properties and functions. The core is where the fusion happens. It's the hottest part of the Sun. Surrounding the core is the radiative zone. Energy travels through this zone as radiation. Above the radiative zone is the convective zone. Here, energy is transported by convection, similar to boiling water. Finally, the photosphere is the visible surface of the Sun. Section 7. Energy's journey. The energy produced in the Sun's core doesn't stay there, it travels outward, passing through each layer. This journey takes a long time. Think of a crowded room. It takes time to move through a crowd, right? Similarly, energy takes thousands of years to reach the Sun's surface. Once it reaches the surface, the energy is radiated out into space as light and heat. This is how we feel the Sun's warmth on Earth. Section 8. Solar wind. The Sun isn't just a calm ball of fire, it's a dynamic and active star. It constantly emits a stream of charged particles called the solar wind. Imagine a hose spraying water in all directions. The solar wind is like that, but instead of water, it's made of protons, electrons, and other charged particles. This solar wind travels throughout the solar system. It affects planets, comets, and other objects in its path. On Earth, it can create beautiful auroras. Section 9. The Sun's influence. The Sun is the most important object in our solar system. It governs the motions of planets and other celestial bodies. It provides the light and heat necessary for life on Earth. Its gravity holds everything together, from the smallest asteroid to the largest gas giant. Its energy influences the climates and weather patterns of planets. The Sun is a fascinating and complex star. By studying it, we learn more about the universe and our place in it.